So in our study of the exponential functions, I'm going to introduce to you the number e. Okay, so this is another irrational number that has a big role in mathematics, as you would see later. So the only, let's say, irrational number that you know is pi, and that is approximately equal to 3.1416, and goes on and on without end. It's an irrational number. Now e is another one of these numbers, and we are going to use, it doesn't end, but we're going to use the value 2.718. okay, so I'm not going to discuss what is e. We don't have time for that now. If you like, or I suggest you Google it and try to study how they were able to get this value. Okay, so you might say, oh, where am I going to use this? It's like pi. You never know pi before, but now when you go to geometry, you're going to use a lot of that. Okay, so e is just a number. It's just, let's just think of it as 2.72 or something like that. So instead of saying 2.72 something, we will call it e. That is the number e. So we can also, instead of let's say, we're going to graph this, okay, because we're going to need this also in our next lesson in logarithms. So if I want you to graph, okay, if I want you to graph, let's say, if I make 2.78, okay, 2.78 as our base, so I could say graph, okay, how do we graph? Y equals, instead of a number here, I will use 2.72, okay, 2.718, okay, raised to x. So this is also or let's just use 2.718. You might think, why dot, okay. So this is an exponential growth because the base is bigger than 2. So instead of writing that, I'm going to write the symbol e to the x, okay? And let's try, so this is the parent graph, e to the x, okay? Let's graph this e to the x. We always use 3 values. We always use 1, 0, and -1. Let's solve for y here. So for e, or 2.718 raised to 1 is also e, or that's 2.718. And x is 0. E to the 0 is 1. Anything raised to 0 is 1. And e to the -1 is 1 over e, or 1 over 2.718. Okay, so let's approximate that. You can use your calculator, okay, to get 2.718. okay, and let's just use the value 0.37. okay, so let's graph this parent graph, 0.37 there. So let's graph these 3 values. X1, 2.7, 1, 2, 2.7 is somewhere here. And then when x is 1, 0, when x is 0, y is 1, and 0.37 is somewhere here. And this will be an exponential growth. Okay, this is the graph, y equals e to the x. And of course, we have our asymptote also here. So that is our asymptote. Okay, let's try to do some transformations on this. Okay, so let's say, for example, I want you to graph now. Okay, y is equal to, instead of e to the x, let's try to graph y equals, let's say, e to the x. Okay, that is the parent graph. Let's put a +4 here, and let's multiply everything by 3. Okay, so can you pause the video and write the transformations that will happen here? Okay, so I hope you did. So we say the parent graph y equals e to the x will, okay, so what will happen here? First, it will, we look here, translate 4 units left, and then this 3 will vertically stretch by a factor of 3, vertically stretch by a factor of 3. Okay, so let's do this. Let's do these two transformations here. So first we're going to translate 4 units to the left. Okay, so this one will be 1, 2, 3, 4. 1, 2, 3, 4. We're just going to slide it. 1, 2, 3, 4. Okay, so we just slide it 4 units to the left. Okay, this is our first transformation, and our asymptote is the same. And now we're going to vertically stretch by a factor of 3. So these are our points. We're going to vertically stretch this by a factor of 3. Stretching means pulling it away this way, pulling it up by a factor of 3. So we're going to get the distance from the y-axis of the point and multiply that by 3. Okay, so this is the one. Okay, so let's just try to approximate that. Okay, or just approximate, this is easier. So 1, 2, and 3. So that is already our final graph. Okay, so let's try this. This is 0.37 and another 0.37 and another 0.37. So it will be somewhere here. And this is 2.7, another 2.7, and another 2.7. So it will be somewhere here. Okay, so that will be somewhere there. Okay, so 5, 6, 7, 8. All right, somewhere here. Let's just, okay, so you see that is now stretched. We cannot stretch this asymptote. It's still the same. It's on the x-intercept. So we're going to have this as our final graph. Okay, so these are your points. Okay, so it will approach the origin. So let's do the summary here. Okay, so so just do the summary. Okay, what is the y-intercept? What is the asymptote, domain and range, and everything, like what we did before. Okay.